Hello, Internet, and thank you very much for joining us on the Cloud Native Islamabad live stream. And today we're talking about how to enable control plane with Crossplane and what happened behind the scene when you enable your infrastructure using Crossplane. And I have a wonderful guest today. He's a core maintainer of the Crossplane project, Daniel Magnum. Thank you very much, Daniel, for joining us. And now introduce yourself and what you do in the company, where you live, and tell my audience about it.
Awesome. Cool. Yeah. Well, thanks for the intro. Definitely very honored to be here. I've been trying to get back on some of these meetups and live streams recently because that's something I really missed doing for a bit there while I was kind of heads down working on some things internally at Upbound, which is the company I work at. And Upbound is where the founders of Crossplane work. And since then, Crossplane has become a CNCF project and has gotten some pretty good adoption. And hopefully some of y'all have heard of it before. Today, we're really going to be talking about what happens behind the scenes, right? So I've given a bunch of talks. We have lots of other folks in the Crossplane community that have given talks about how you use Crossplane. And we're going to use Crossplane today, right? We're going to go through the actual steps of the quick start. But instead of saying, okay, this is just the end user experience, we're going to try and dive down another level, both for anyone who, wants to get involved with contributing or modifying or anything like that, but also just to gain, a greater understanding of a user and to kind of understand how to troubleshoot something if it goes wrong, or maybe where to poke around if you're seeing behavior that's unexpected. So yeah, I'm definitely very, very excited to be here, and I think we're going to have a lot of fun.
Yes, absolutely. If you want to share your screen and talking about Crossplane, you can do with it. So let me give you a small intros of myself, what the Crossplane is. We all know in the Kubernetes area, all of your application blueprints are packaged into a lot of Kubernetes manifest files, or maybe also packages as chart using tools like Helm. So how do you create any cloud resource on the cloud? You can maybe use external Terraform module or create the resource, use a Kubernetes job and create the resource using AWS SDKs, or use a bash Python script and internally call AWS CLI command. But how reliable is this? Unlike Kubernetes manifest, in which the YAML file can be adjusted on the fly, every time an attribute changes, you will have to explicitly call these dependent resources. And in the modern GitOps era, having such external dependencies might not be a feasible option for your GitOps solution. So how do we fix this? Here comes Crossplane in picture. Crossplane enables you to provision, compose, and consume infrastructure in any cloud service provider using the Kubernetes API. Using Crossplane, you can create resources on the cloud using simple manifest and can then integrate in this with your CI/CD or GitOps pipeline. So this is my quick intro of Crossplane, and now it's going to the Daniel to start telling about what the behind the scene, what happened when we enable this structure with Crossplane.
Awesome. Awesome. Thanks for that intro. I think that was a great description. Really, I'll go ahead and start sharing my screen here and make sure it's coming through. Let's see. Alrighty. Looks good to me. And so, yeah, that's exactly right. Crossplane does allow you to consume infrastructure via the Kubernetes API. If folks are familiar with, how the Kubernetes API server works, it comes with some built-in types, those pods, deployment services, things you've all used if you've used Kubernetes. Also allows you to extend the Kubernetes API with your own types. And we use something called a custom resource definition to be able to do that. Crossplane really leans into using custom resource definitions. And basically, if you think of any REST endpoint that a cloud provider or really any external service, so any API that's available over the internet, presents to a end user via an SDK or via the API directly, we represent essentially the body of that request as a CRD. And we allow you to create an object of that type in the cluster. So the canonical example we talk about a lot of times is like an RDS instance on AWS. So imagine just like you create a pod, or maybe put a pod manifest, or more likely probably a deployment manifest in a Helm chart, you can also put your RDS instance in that Helm chart. And then Crossplane does some nice work to both provision that and get you connection secrets to be able to talk to it from your application that's consuming or writing to it. So that's kind of a very scoped example, but that's the one we're going to focus in on to start off. And then we're going to build into how Crossplane actually goes much beyond just provisioning infrastructure and allows you to build a platform. And when we say platform, we really mean that you can consume those external APIs. You can take advantage of cloud providers and all the great work that they've done to make it really easy to build software these days, and compose those into your higher level abstractions. But I want to go ahead and jump into it. It's going to be very hands-on. Definitely encourage anyone to leave things in the chat here. I've got it going. Or if you want to, pop up and interrupt or anything like that, totally open to it. It's going to be very hands-on. And so let's get right into it. What I'm sharing here is an Excalibur diagram. And so I'm going to do a little bit of an experimental presentation style today, where we're kind of going to build the presentation as we go along. I'm a big fan of creating diagrams. If you follow me on Twitter or anything like that, you've probably seen me posting diagrams for Crossplane or Kubernetes or RISC-V and other things. So we're actually going to kind of put together some of these steps and visualize what's happening as we go through the quick start guide for Crossplane, and then also build on it a little bit. So here I have our diagram, which we are going to add to, and we're going to have steps as we go along the way. I also have the Crossplane repo checked out locally here, and we're going to look into the source code a little bit and see what's going on there. And lastly, I have Crossplane docs open here, and we're going to be broadly going through the install and configure and then provision and create configuration steps here. But we're going to dive into a little bit more about what's happening behind the scenes. All right. So to start off here, let's go ahead and just create a local Kubernetes cluster. And I'm going to use kind to do that, which is essentially running Kubernetes in Docker if you haven't used it before. This should spin up pretty quickly. And we're going to start off with our, let me pull it back up here, with installing Crossplane. So what we're going to do is create our Crossplane system namespace, and then Crossplane itself is installed using a Helm chart. And then going forward for configuring the control plane, which is what we call a Kubernetes cluster with Crossplane installed, we're going to be using the Crossplane package manager as opposed to something like Helm or Customize or something of that nature. And we'll talk a little bit about some of the guarantees the Crossplane package manager gives you after we actually install a package. All right, so I'm going to go ahead and take this. So once again, creating that namespace and then installing Crossplane into it. All right, so I should have a cluster up and running here. We've got our normal pods in the kube system namespace. And let's see if we can get this installed. All right, so it looks like I have the latest version of Crossplane going in here, 1.9.1. So let's look at what actually got installed, and then we'll actually look at the Helm chart contents to see where that came from. So first of all, if we look at our pods again, you'll see we have our Crossplane system namespace, and we have 2 pods in there. Crossplane can be deployed with just the core Crossplane deployment, which is this one. But typically is installed via the RBAC manager, which is very critical for doing things like composition, which is kind of how you get to building your own platform on Crossplane. So once again, if we looked at up a level, we could see that we have some deployments here. If we looked at our service, we don't have any services deployed, so it's pretty simple installation. And let's actually go ahead and jump into the Helm chart here. So this is just in the Crossplane repo, so you can follow along if you like. So if we go in cluster, charts, Crossplane, this is the source for the Crossplane Helm chart. If we look at our templates, we primarily have our Crossplane deployment here, which is just going to be installing Crossplane, and we're going to give it our core and init flags, which is basically saying run the core Crossplane process and install the CRDs that are necessary for that. We also have the ability to specify some providers and configurations, which we're going to define in a bit, that can be installed alongside Crossplane. But mostly this is just kind of your run-of-the-mill deployment here. If we go back out and take a look at the RBAC manager, we similarly have a deployment here. And we also have some interesting RBAC primitives that are installed. So if we look at allowed provider permissions, you're going to see we have this aggregation rule. Aggregation in Kubernetes RBAC allows you to basically have a set of permissions bubble up to a single role that can be assumed. And we use that in a variety of cases. Namely, maybe the most critical place where we use that is where we aggregate. I need to go one up from there. Where we aggregate permissions to Crossplane itself. So I mentioned earlier that when Crossplane is installed, we now have a package manager which can install some other things for us. The way that Crossplane is able to create the resources that are installed by the other packages is by aggregation. So let's say we bring a package along. Provider AWS is what we're going to use in just a moment. We're going to take the resources that Provider AWS has installed and aggregate permissions to create instances of those. So maybe like an RDS instance. And that allows Crossplane to let you define higher level abstractions on top of that RDS instance. And you create the instance of the higher level abstraction, let's say a database, and an RDS instance is created by Crossplane. So it needs to have permissions to be able to manage all the different things that gets installed. The RBAC manager is responsible for managing those permissions, managing RBAC, as you might guess. And it's also responsible for giving permissions to the providers itself. So provider AWS also needs to be able to manage that RDS instance type. For when instances get created, it needs to be able to create the RDS instance on AWS. So really, we're just kind of doing some various ownership work here with the package manager. I know that's a lot of information, and we're going to dive into a little bit more what that looks like. But before we do that, let's jump back over to our diagram and talk about kind of what's gone into our cluster. So we have our Kubernetes cluster here. We have our Crossplane system namespace. We didn't take a look at yet our CRDs. We should see what those are here. These are all Crossplane types that were installed alongside with Crossplane. Primarily today, we're going to be focusing on providers, configurations, and composite resource definitions and compositions. So 4 types there: providers, configurations, compositions, and composite resource definitions. And we'll define those more fully in a bit. But essentially what we have in our cluster at this point is our Crossplane pod. So we'll call that XP here. We have our RBAC manager pod. We'll call that RB. And then we have a set of CRDs, which have added new types to the cluster here. So we'll say this is our provider. This is our configuration. So we'll say this is CF and PR. And this is going to be our composite resource definition. So different than a CRD. We're creating, we'll get into what that does in a minute, but basically it proxies creating custom resource definitions on our behalf. And we also have our composition here. So broadly, this is a very simplified view of what our cluster looks like. And Crossplane has controllers that are set up to reconcile all of these different types. The provider and configuration are the 2 package types that Crossplane offers. So let's go ahead and take a few notes on that. So providers, they add CRDs. They add new CRDs to our cluster and start controllers to reconcile them. And then configurations add XRDs to our cluster and add compositions to our cluster. So these are the two package types, and we're going to talk about what a package actually looks like here in just a moment. But if you have any questions on these types that are now available in our cluster, please feel free to go ahead and drop those in the chat. So with Crossplane installed, we have everything running. We have these different types, and Crossplane is running controllers to watch all of these different types and act on their creation, right? So it's your typical kind of Kubernetes controller setup. Crossplane is just a set of Kubernetes controllers. If you wanted to get into the source of where this lives, you can always jump into our internal directory and look at controller. API extensions is where compositions and composite resource definitions live, and the related kind of controllers to those, which are really interesting, and we're going to get into further down the line. And then package is where our controllers for providers and configurations live. So we'll come back to that as well here in just a moment. If we want to look at where we're at in the Crossplane docs, we've essentially just installed Crossplane and talked a little bit about what's there. I already have the Crossplane CLI installed. It's just a kube control plugin that does some kind of simple additional things to add commands for you to be able to run. In the Crossplane docs, we start off by installing a configuration package, right? So a configuration package was the one we saw just a moment ago that adds XRDs and compositions to our cluster. We're instead going to start off with a provider because configurations often depend on a provider. But the provider is really what brings those primitive new types. So if you want to add support for AWS to your cluster, you install the AWS provider. So we're going to start off with doing that and then look at how configurations build on top of it. So our next step here, install provider. Let's again have our cluster. We have our Crossplane system components up above, which we already chatted a little bit about. We can just bring this down. All right. And put it up here. And we can install a provider with kubectl Crossplane provider. I believe it's actually install provider, and then the reference to the OCI image. So in this case, we're going to say install provider Crossplane / provider AWS v0.31.1, which I believe is the most recent release. So keep in mind here that this is in fact an OCI image. So if you've seen recently more and more bundling of resources and data are being packaged into OCI images, Crossplane's been doing this for quite a long time. And essentially what these OCI images have in them is a controller as well as a bunch of YAML that we unpack and apply in Crossplane. But doing this is actually just going to create a single type in our cluster of this provider kind. All right, so you'll see that we have it installed. We can use the shorthand of kgit package, which will give us all providers and configurations that are installed. So we'd expect this to see just this single type here. And it may be that I got the version wrong, let's describe this provider here. Yep, it looks like that is not a valid version. So let's actually look and see what the latest one is. Crossplane contrib is where all of our providers live. So our latest version is v0.31.0. So if we want to update that, we can actually just do same command and edit it. All right. So this is what our provider looks like. When I ran that kube control command, the kube control crossplane install, it basically just rendered this manifest and applied it. So all we've done is create an instance of this provider type up here. And what we want to do is go ahead and change this to 31.0, and updating that should see us move forward here. All right, so you can see it is installed now, but we're waiting for it to become healthy. So installing this package, creating this provider type, causes Crossplane's package manager to see that a new provider type exists and say, okay, I need to pull down that image, unpack the contents, install all the CRDs that are included, and then start a controller to reconcile those CRDs. So if we wanted to look at our CRDs now in the cluster, you'll see that we have many, many more CRDs for all the different types you would expect from an AWS cluster. And so let's look at what that looks like kind of in our diagram here. So we created a instance of a provider, right? So this PR type. So let's say it is, I'll make this small, kind provider. And we'll just say that metadata name, and we'll just call it AWS for now. So we created an instance of this provider type. Remember that Crossplane installed the CRD, which defined the type. Right, so we have our provider here. So we installed that type, triggered Crossplane's package manager controller to see it and say, okay, I need to take this image, pull it down, look at the contents, and apply all of the CRDs that are in a YAML file in this package. So if you actually wanted to dig into this a little more, you can use this fun little site that lets you kind of crack open images. So I'm going to go to Crossplane provider AWS v0.31.0. And we'll do the AMD 64. And if we look at the content of this image here, you'll see that we just have this package.yaml file, one file in it. And inside of it is custom resource definitions. And you'll see there's quite a few of them. In fact, they're not all loading for me here. And these are all of the types that Crossplane pulls down the image, cracks it open, and installs into your cluster, adding each of these types. If we now look at the pods in the Crossplane system namespace, we're going to see that we also have this Crossplane provider AWS pod running. So if we wanted to show this a little more completely, we now see that in our Crossplane system namespace, we also have it's a little smaller, an AWS pod. And really, each of these CRD types, right, would be at the cluster scope. But we'll leave them here for the time being. And we now have a bunch of new CRDs like RDS and EC2, maybe Lambda, right? All the different AWS types here. And our controller is watching them. So just like, well, that wasn't very helpful. Grab another one here. Just like Crossplane watches these kind of system types, AWS now has a pod that is watching and reacting to creation of these different types. Once again, if anyone has any questions, feel free to go ahead and drop them in the chat here. But what we've done is one, installed provider AWS, Crossplane, installed CRDs for us. Over. Crossplane created a deployment for provider AWS with controllers that watch the AWS types. So at this point, we have a pretty good setup to be able to provision infrastructure. But before we do that, we actually need to configure provider AWS to talk to our AWS account. So if we wanted to do that, we could hop over here to the Crossplane docs. And we have some information about how you can create a secret for your AWS credentials. So I'm going to go through doing that. And let's see if we have our creds.conf here. Like we do. And we can create a secret in the Crossplane system namespace here. We're going to call it AWS creds. So let's take a look at that. All right, our AWS creds has our data in it. And the last thing we need to do is something that's convention for all Crossplane providers. And that is to create what's called a provider config. Flipify provided grep there. So this provider configs.aws.crossplane.io is essentially a credential profile. At least that's how I like to describe it. You can have as many provider configs as you want. And essentially what it means is that when you create a resource, you point it at a provider config, and it says, hey, use these credentials to provision this resource. So in this case, we can create a provider config that points at those credentials we just created. So this is exactly what the content looks like of what we'll create. And we're saying, hey, the name of this provider config is default. And the credentials that should be used are sourced from a secret. And that secret is with this name and this namespace with this key for the secret content. So I'm going to go ahead and create this in the cluster, and then we'll update our diagram again to show where we're at. All right. And get our provider configs. We have default. Looks good. And the default name means that if I don't specify which provider config to use when creating a resource, then it will use the one named default by default, as you might expect there. All right, so we've gone and we have taken this. Let's see if I can move that again here. There we go. We're getting a little cluttered here, but we're going to try to keep it going. Let's take our provider config, and we said it was named default, and it points at a secret. I'm going to delete this namespace box because it's not quite accurate at this point. I'll move this up. And we can just say we have a secret here. And I believe we called it AWS creds or something of that nature. Alrighty. And this points to that. So nothing's really happened yet. We've just created a resource in the cluster that says, hey, these credentials exist in this secret. So let's note that down. One, we created a secret with creds to access our AWS account. Two, we created a provider config that points to the secret and explains how to extract creds from it. All right. So nothing too crazy quite yet. Let's move on to actually provisioning some infrastructure. All right. And we can expand our cluster a little bit. Next thing we're going to do is create an RDS instance. And to do that, let's actually take a look and see if there's any good examples in our provider AWS repo. Alrighty. So if we go down and look in database, we can look at RDS instance. And here's an example of what an RDS instance might look like. Once again, this is a type that was installed when we installed the AWS provider. Right, so we have a couple different things. We're looking at this RDS instance type. And the fields here are exactly the same as what you get from the AWS API. So if you were creating this via the SDK, or you were, curling the REST endpoint or anything like that, then that's what you would use. So you'll notice this provider config ref. If we look at any of the resources here, they all support the provider config ref field. So the convention is that you have a spec on each resource, and of course you have a status that gets populated after it's created. And then the for provider section of a managed resource. A managed resource is the generic term we call types that are installed by providers. The for provider section of the spec is the one that maps one-to-one with the external API, right? So the one that mirrors the request body you would send to AWS. And then additionally in the spec, there's going to be other fields like this provider config ref and like write connection secret to ref. These are present on all managed resources and allow you to do system level things like tell what credentials to use or tell where to write the secret to in this case. So let's copy this one down here and we can just say rds.yaml and we'll insert this in there. And I'm going to say, actually, let's demonstrate that we don't want to actually create our provider config ref, and we instead want to omit it and fall back to the behavior of using the one named default, right? When we created our provider config ref, it had the name default. If we don't provide a provider config ref, then it's going to default to using the default provider config ref. All right. And I have no idea if these credentials are correct here. So we'll see if the RDS instance actually gets created. But if they were, it certainly would. And if it doesn't, then we can see exactly what's happening here. So let's see. We were able to create one successfully. And you'll see that we get some fields here that give us information about this resource. And we get synced false. If you want to determine what's going wrong with a resource in Crossplane or in Kubernetes in general, frequently looking at the events and the status are good options here. The events are particularly useful in Crossplane where we tell you why a certain status might be happening. So if we describe this, we'll see cannot describe RDS instance, failed to sign request, failed to retrieve credentials, static credentials are empty. So what happened there is that the secret that I created didn't actually contain valid credentials. If we looked at our provider config ref, remember we omitted that, it was using the default credentials or the default provider config ref, and it followed that. So in the chain for provider AWS, it looked like this. We created our RDS instance. Got a little wider here. And let's see, what did we call that? Example RDS. Right. AWS, provider AWS saw that. And it saw that the provider config pointed to default. So it then got the default provider config, got the secret pointed to by it, and then tried to issue a create call to the RDS endpoint on AWS. And that informed it that the credentials were invalid. Or in this case, I believe it informed it that the AWS credentials just did not exist at all. But that's an example of what it could look like if you did have valid AWS credentials. You would be able to perform this. I'm not going to get too much into provisioning infrastructure directly on this because we just want to talk about the internals. But broadly, this flow, when you're just using managed resources directly, Crossplane is not really involved. So it's kind of cut off here. Let's see if we can bring that down a little. Crossplane is pretty much cut off at this point, right? These are all acting in the AWS land. And that's great. But what we want to be able to do is build a platform, right? That's kind of the idea of what Crossplane enables you to do. So in your cluster, in addition to having all of your, pods, deployments, etc., you also have things like RDS instance, EC2 instance, etc. That's great. You can create all of those. We just showed creating an RDS instance. What we'd like to do on top of this is compose our own APIs. So the RDS instance API is pretty verbose here. We saw pretty much the simplest example, or one of the simplest examples you could look at with our RDS instance here. But that's a lot of different fields. Most folks are not going to want to configure that all the time. And if you're a platform engineer and you're trying to build a platform to give to developers, think about giving your developers kind of a Heroku-esque platform, or whatever your kind of favorite layer 2 cloud provider is. You would want to present them with a simpler API. So let's take a look at a similar example and actually use what the quick start guide tells us to do, and that's install a configuration. So a configuration contains, let me hop back over. Configuration, as we mentioned earlier, contains XRDs and compositions. So with these types, RDS instance and EC2, we created CRDs to add them to the Kubernetes cluster, right? If we want to create our own types, we don't want to have to write new controllers when we're really just mapping an API to one of these underlying types. So if you wanted to create a database type and present that to your developers, and when they created it and it had kind of a friendly interface here, let's say it said something like, we can just look at what the Crossplane docs give us. Let's say it just had something like the storage size. This is what you wanted to give to developers, that you say, hey, create a database, and all you have to do is specify the storage. But in return, you want an RDS instance to be provisioned. Let me redo that. Right? If you want an RDS instance to be provisioned, you don't want to have to do all the work that the provider AWS maintainers do. You would prefer it if you didn't have to write controllers and run your own deployment. All you're doing is saying, hey, I want to take this storage size and map that onto an RDS storage size. So if we look at our RDS instance again here, we have all these different fields. And if we want to look for storage, we have our storage type and storage encrypted. So this one, allocated storage, is the one that we care about here. We want to specify the storage size. So let's say every time we create an RDS instance, all of these fields are the same except for our allocated storage size. It'd be a real bummer if we wanted to create a database and have it only expose this one field, and we had to write a new controller just to take that database, produce an RDS instance, and then have AWS, the provider AWS, reconcile that and create it. So Crossplane instead allows you to template this out. So let's look at what that looks like in the Crossplane docs by going to the create a configuration section here. So I'm going to grab the contents, and we'll say this is our XRD here. An XRD is what you use to define this higher level abstraction, right? In this case, we're calling it a Postgres instance that we want to create. And so we're basically defining the API that we want to give to developers. If we go down into the schema, we're defining our one storage GB field, and we're saying that it is of type integer and it is required. So the developer, when they come in, their interface to creating an RDS instance, for example, looks just like this, which once again is quite a bit simpler than all of the fields that we have here. It's also generic, right? Storage GB is not specific to AWS. And if you actually look through the different quick start guides, you can see that they all use the same type and the same schema, but they're provisioning resources on different cloud providers. This still has value even on a single cloud provider as well, right? You can just present a simpler interface and have that map directly. Now, if we go back to our diagram here, this is conceptually what it looks like. But what about this stage here? How do we get the storage GB field to the appropriate field on the RDS instance, or maybe, for that matter, on the RDS instance or the Cloud SQL instance, right? If you wanted to have it be able to map to either AWS or GCP, how would you define that when they have different APIs that you're targeting? So we said the XRD is how you define the database type that exposed that storage GB field to folks. We just need to define this mapping, which is essentially taking the place of what a controller would do when it takes input and produces some output there. So Crossplane gives you a type called a composition to be able to do this. So this is of type XRD. And these are defined using CRDs directly. And our composition, for AWS at least, is going to look like this. So let's pull this down and get it ready to go. Oops, save that. And we'll call this comp.yaml. Paste it in. And if we make this a little bit smaller, you're going to see that our composition here is specific to AWS. It defines some labels that we can select on. and it has this composite type ref. So this maps to the higher level abstraction that we created, the database XRD. This composition says, hey, I'm a candidate for satisfying this XRD type or this API type that's been added to the Kubernetes cluster. And when I satisfy that, I want Crossplane to take this template that I have and the resources, and I want it to create an RDS instance with these fields. And I want it to take the field from the database type and map it to this allocated storage field on provider AWS. So ultimately, we get an RDS instance that looks not too dissimilar from this one, created in the cluster, just like we did directly. We now have one level of indirection from that, and Crossplane manages the translation from our generic abstract type, the database, to the RDS type, propagating the fields to the appropriate fields within the RDS instance. So if we create an XRD in the cluster, we'll show doing that first. And if I could save these, that would be good. So an XRD, a composite resource definition, is slightly different from our custom resource definition, but it results in the creation of custom resource definitions. So we can apply this directly. And we see our composite resource definition was created. And if we do a git f on that, we can see that it is established and offered. What this basically means is that Crossplane has created an XRD at both the cluster scope, has created a CRD that is cluster scope and a CRD variant that is namespace scoped. So if we looked at our CRDs here, let's look at, for example, we're going to see we have a Postgres instance type. This is the namespace variant, and an X Postgres instance type, which is the cluster scoped variant. So once again, we applied our composite resource definition to the cluster. Let's just create another one of these because I'm getting a little unwieldy. We created our XRD and Crossplane saw the creation of the XRD, and in response created 2 CRDs. And the reason why we need to be able to create those CRDs is we want the user to now be able to create a database instance type, or in this case, a Postgres instance type. And to be able to do that, we have to add that API type to the Kubernetes API. So that's how we're able to do this now. And if a developer wanted to come along, and let's go ahead and delete our RDS instance that we provisioned before. All right, so that's deleted. And let's apply our composition, which tells Crossplane what to do in response to a Postgres instance being created. All right, so our composition exists. So if we look at our XRDs, we have our X Postgres SQL instance, which results in the creation of these 2 CRDs. And then we also have our composition, which says this maps the X Postgres SQL instance type to an AWS concept of a database. So the last thing we need to do is go ahead and create a claim for this. So we can take this one here, and we're going to specify we want the AWS composition. Now, we only have one composition created, but these label selectors are going to match to what we put on the composition here. So we have these labels. If we supply these when creating, then it's going to match to the one that has the label selector as a match to it. In this case, we only have one, so it's going to match by default. But let's go ahead and create our claim. All right. And if we wanted to get that, we're going to see that it has some status, but it's not ready yet. Okay, so when we created the database, right, we're the developer and we want to be able to create a database, we would expect for Crossplane to take the parameters on our database, map them to the RDS instance type, and create an instance of that RDS instance in our cluster, just like we created the RDS instance ourselves earlier. So we should see, even though we deleted our RDS instance, we should see a new one that's been created in response. And there we see that we have one. And if we wanted to take a look at this more closely and look at our allocated storage, we'll see that it has 20, just like our database type had. So let's get our, actually, let's go ahead and just edit it. Our storage GB here. And let's say that we now want it to be 30. Crossplane is going to see that update. It's going to once again template out the RDS instance. And we should see eventually our RDS instance get updated to also have allocated storage of 30. So we've basically created a generic controller that can do mappings based on the types that we create, based on the XRDs and compositions that we create in the cluster. Now, we don't have too much time left, so I noticed that it looks like we need some higher resolution on the live stream here, so we'll make sure to do that next time. But the last thing I want to do is talk about how you can package up these abstractions, right? So I'm going to go ahead and delete our claim. And we should see that our RDS instance also gets deleted. And we can delete XRD and compositions. So all we have left is our package of provider AWS. So what I'm going to do instead now is go ahead and delete our package. So back to square one. And instead of manually creating those compositions and XRDs here, I'm going to package them up into a configuration package, which we said earlier is how you can deliver abstractions. So once again, our compositions are how we add XRDs, or our configurations are how we add XRDs and compositions to the cluster. The other thing it can do is depend on a provider. So in this case, we have an XRD that defines our database. We have a composition that matches that to the RDS instance. If provider AWS isn't installed in the cluster, it's not going to work for us, right? We're not even going to be able to create that RDS instance type because it hasn't been installed. So what we'd like to say is in our configuration package that we can put our XRDs and compositions in there and then say to Crossplane, hey, also make sure provider AWS is present in the cluster. So if we go to Crossplane docs, you'll see how we can actually go about doing that. We already took our XRD here and our composition. And the last thing we need to do here is create this crossplane.yaml. Okay. And let's make a new directory here for package. Crossplane.yaml. And here we're saying that this is our getting started with AWS package. It says we need at least Crossplane v1.4.0, and we want provider AWS to be installed at this version or greater. Crossplane is actually going to resolve this to the latest version of provider AWS when it gets installed. So we'll save that. Let's go ahead and move our XRD to here, and we'll move our composition to here. Right, so we have these three YAML files here, and we're going to use the Upbound CLI. You can use any image building tool to go ahead and construct our image here. And you're going to see that we now have this X package file. And this can be pushed as an OCI image to any registry that you like. So I'm going to create a repository on Upbound's registry. And I can actually do that by saying, I want to push this to Dan, getting started with AWS v0.1.0. And I can pass this create flag, which basically says, hey, if this repository doesn't exist, go ahead and create it. And we'll see if I'm actually logged in here. It looks like I am. And if we wanted to see our repos now in my org, we can see that we created this getting started with AWS repo. Upbound was able to figure out that this was a configuration, and it's a private repository right now. And so to install this, we can go ahead and create a pull secret in our Crossplane system namespace. Let's see here. Pull secret, create, here we go. And system. All right, so it's using my user credentials, but we have this package pull secret type that's going to allow us to install a private package, just like you'd use image pull secrets for. And then I can say control plane configuration. And we want to say install. And I want Dan getting started with AWS v0.1.0. And I want to specify that our package pull secrets should use package pull secret. And see that? All right, so it is installed. If we look at our package now, and this is the last thing we'll do, we'll see that our getting started with AWS package was installed, and it pulled that from the Upbound registry. But we're also going to see that provider AWS was automatically installed, right? We had previously gone and deleted that, but we need that present for our types in our configuration package that we built to be able to work correctly, right? For us to be able to create an RDS instance. And we should see this come up. Yep, it looks like it's coming along. And all of our CRDs for AWS again are once again going to be present, as well as our XRDs and our compositions. All these things we created manually are now able to be installed with a single command here. Furthermore, you could take that database type or this Postgres instance type that we offered, and you can give that to folks to actually build a higher level abstraction on. So in this case, we only have that one allocated storage or storage GB field on our type. But if we had more, you could take your abstraction and build an abstraction on top of that, or you could combine it with some other ones via that dependency mechanism that Crossplane already resolves. So what we've seen here is we are able to package up configuration data into a configuration package with our XRD and our composition. We're able to say for this higher level abstraction we created, we depend on AWS, and installing that was able to both bring our higher level abstraction, its mapping to the AWS concept, and install provider AWS to make sure that it's created correctly for us. And if we wanted to go in again and do our provision infrastructure, we can see that, again, RDS instance created. All right. So I know that was kind of a whirlwind. I mentioned before we got started that I would love to come back and chat more in the future because I know there's a lot of moving pieces here. But hopefully, this gave you a little bit of a behind the scenes look at what you can do with Crossplane. I think you might still be on mute.
Yes, yes, I really enjoy it and see so many people from the India, from the China, from the Dublin. Robert is saying thanks so much for organizing this Crown at Islamabad. Hi Dan, thanks for the presentation. And I have to drop off, so he have to drop off. Another Walid is also joined, and he's saying that along say in one of the batch group working group discussion that they were discussing crossplane, what would be the context for HPC workloads and create HPC work cluster resources. Can you address this, Dan?
Yeah, so I can't speak directly to the conversation they're having, but it is broadly applicable to when folks want to be able to manage potentially multiple clusters or multiple nodes or something like that. Today, we are talking about databases quite a bit. A big use case for Crossplane is to manage other Kubernetes clusters from a single Crossplane installation. So I could see that something like high performance computing where there's potentially a large distributed system, or just any dependence on infrastructure automation that you want to handle via Kubernetes, Crossplane being applicable there. But if anyone is part of that community, definitely feel free to reach out. I'd love to chat with y'all and see how you're using it.
Yes, absolutely. I think the crossplane is everywhere. AWS, Azure, GCP, all the cloud providers supporting it, and then the smaller one is also is catching an eyes on crossplane as well. And we definitely had have a more conversation around crossplane as the things we go on. So before you go, let people know because the KubeCon is coming up next month, 26th of October. So quickly tell people about what the topics and the talks are discussing there around crossplane.
Yeah, so there's going to be a lot of talks about Crossplane. I can't enumerate all of them because some of them are from some of my coworkers, some of them are from community members, some of them are just from end users. I can speak to what I'm going to be talking about, which is kind of a proposal that I want to bring forward for how we manage types across Kubernetes clusters. So today we were, focused on one Kubernetes cluster with Crossplane installed in it. One of the things that we see is when we're packaging up all these types into OCI images and being able to install them, like we talked about there, there's this dependency tree you get with types that are present in the cluster. So we define this Postgres instance type that mapped to an RDS instance. But really, the thing that identifies that RDS instance is just its group version and kind, which is unique within a given cluster. But when you start to expand that to multiple clusters, group version kind is no longer unique, right? It's not a unique attribute across it. You could create an RDS instance type that has some schema that you like. I could create one that has some schema that I like. And how does that package know, that it's actually relying on the correct one? And what I'd like to do is us to kind of take a page out of the content addressable nature of OCI images and think about how we can actually explicitly specify based on the content of types what the dependencies between them are. So I'm really excited to chat about that. It's kind of a subtle thing that I think a lot of folks aren't exposed to quite yet. But I think as we start to move to more of a multi-cluster world, it starts to become really important.
Yes, absolutely, absolutely, and wonderful comments and wonderful thumbs up for the Dan talk as well, and that's a super talk to address on. So before you all go, let me share the quickly links for you to where you go next and learn more about it. Here is a website for the Crossplane IO. It's a Twitter handle. You can see all the latest updates around what happening with the project. It's a GitHub repository. Try to add new things on it and send a PR about the things that's missing in or is an issue or tell people about I'm interested in seeing these kind of solutions in the crossplane. And here is a new talk. I think the vector is giving Victor Fossig how to solve crossplane composition complexity using issues with YTTT from I think this is a tool from VMware. And also there's another wonderful talk by the Victor Fossig on GitHub's based infrastructure as code through Kubernetes API. Also, the Rock OD has a live stream on Crossplane in Action. And here's another deep dive by the Daniel Magnum on Sam Patek show, the Crossplane composition deep dive. And here's a KubeCon talk. I really learned a lot during today is called Crossplane Intro at Deep Dive KubeCon EU 2022. So these are the resources available for you. I'll include them in the chat as well. So hope this will be a wonderful learning experience for everyone. And in moving forward, it is a go-to resource for everyone who wanted to learn cross-plane underneath what's happening behind the scene when we provision infrastructure. So thank you everyone for showing us tonight. It's been a wonderful talking to you, Daniel. Hope to catch up with you again in the future as well. Stay safe, everyone, and stay healthy. Bye bye.
All right. Thank you.